Preparing the meter and testing the voltages. Connect the black lead to the common, connect the red lead to the voltage, the positive connector. Turn on the selector to DC volts. If the meter has an AC to DC switch, set it to DC. So we're looking for DC volts. And place the meter's black ground lead on the black wire connection and its red on the positive lead, the 12 volt connection. Record the voltage. A good power supply provides between 11 and 13 volts DC. Now, okay, so let's finish going through these. Replace the power supply if the voltage reading is less than 10. So if it's 2 volts off, done. If it's 2 volts over, done. If no voltage is present, check for problems other than the power supply. So if you don't have any voltage, maybe the main power, the step-down transformer blew or something like that. Power supply is divided into many discrete sections. So this needs to be done while the power supply is providing power to a motherboard. If you turn on a power supply and there's nothing connected to it, you will damage the 5 volt and the 12 volt rails. They are not designed to be used dry. They have to be connected to something. Otherwise you will blow them. So you need to do it while it's plugged into the motherboard. So they make special connectors for this. Don't go sticking those probes on your motherboard. You're just asking for trouble. Don't use a meter on the computer unless you know what you're doing. You need to use the meter on the wall. That's it. And then you need to be shown properly how to do that. It's very dangerous stuff. If you have frayed wires, that will light you up just like touching the outlet, right? You think about these things. Isolating the problem. So we want to disconnect the Molex leads from the power supply. So the Molex lead, we pull it out of the power supply of the hard drive, say. Connect the meter leads to the red. Actually, you want to stick them in the back, right? You want to stick them in the back because if you put them in the front, they could short out and touch. And then you want to turn off the AC power, disconnect all Molex plugs from the devices, turn the power back on and test for power in the motherboard. Reconnect each Molex one plug at a time and test the power each time. Identifying the offending device, the one connected to the meter when the power drops out. So whenever you're connecting Molex power leads to the devices and all of a sudden the power goes low or the voltage drops, that's the device that's sinking all the current. Probably a short in there or the motor's messed up, something like that. It's trying to pull too much current. So power supply operation. So let's take a look at what we have here. We have 120 volts coming in on the left, and then we have a minus 12 volt DC rail, minus 12 volt DC rail, a 0 volts DC, plus 5 volts DC, and plus 12 volts DC. So one of the ones on the bottom is supposed to be a minus 5 volt rail. So that's incorrect. So let's see, we have a switching network, again from the left to the right. We have a switching network, a transformer, and a voltage regulator. So what does the switching network do? A switching network provides the line conditioning and houses a fuse, capacitors, rectifiers, and switching transistors. So that's what's going to take the AC power and then feed it to the transformer. The transformer reduces the square wave DC into separate 12 and 5 volt square wave AC circuits. The voltage regulator receives the low voltage AC out of the transformer and converts them to clean DC power. It houses rectifiers, capacitors, and coils. Well, what's a fuse? So we have symbols for a fuse over here on the left. The fuse serves for the purpose of failing when there is a power overload on the system, thereby cutting the power supply. So the fuse gets hot and it melts. There's just a little piece of wire in there. It gets hot and it melts right in the middle. Two metal caps are connected by a wire. The thicker the wire, the more current it can conduct, hence the higher value of the fuse. 5 amps, 10 amps, 15 amps, 25 amps, 35 amps. The amperage stamped on the metal cap indicates the maximum current the wire is rated to conduct. If a fuse is in a specific location fails more than once, the system is being overloaded and you need to isolate the problem. You need to investigate. Something's pulling too much current. A capacitor, here's the symbol for it. We've talked about these. You see the picture of the can over on the right. They have a distinct polarity, a negative and a positive on their leads. The longer the leg on the capacitor is the positive pole. In PCs, the capacitors regulate the flow of current to areas of the system circuits. An electrolytic capacitor can hold a significant charge for long periods of time. Any residual charge must be released. Failure to follow safety procedures can result in injury or death. There you go. Don't mess around with these things. They can kill you. They can hold that power for years. And if you find one out in the wild, it's just laying out there in the ground and you're like, man, I want to take this home and play with this thing, then short those 2 leads on a piece of metal, okay?